let's go over the program we use for life cycle cost analysis, and just go to the worksheet of this lesson. And we have two problems with the same data. The first problem that we have to determine the whether we go with the conventional HVAC, heating, ventilation, and air conditioner system, and that we call it base case, with the alternative called A that includes several energy saving features. That one example, it can be applied to many other scenarios that involve comparison over a life cycle project and include another aspect other than the initial cost of the project, including the construction project or one system like HVAC in this case. And to do that, we have collect the data, and in this case, you see the base case and alternative with the initial investment costs for different scenarios. Base case 103,000, 130,000 for alternative A. The discount rate is 6%, and fuel type 12 cents per kilowatt hour. Useful life 20 years. Base date, let's change to January 2023. That's what I'm going to demonstrate in this video. And we have replacement cost for the fan at year 10, and then at year 10 for 12,500 for alternative A. The GDO, it means the service value at the end of the project life, 3,500 for base case and 3,700 for alternative A. The annual electricity costs basically used for this system base case 250,000 kilowatt per year, and then 200,000 for the alternative. Operation, maintenance, and repair costs, OMR, 7,000 for base case and 8,000 for alternative A. And with that, we want to see which alternative we should choose, whether we're good with the base case or we upgrade with more initial cost, 27,000 extra, whether that got to invest more or not, right? So in calculation, hand calculation, we already calculate the width by hand. So you have draw the gas flow diagram for two alternative, base case BC and alternative A. And then we calculate the net present value for each. And in this case, we consider the cost. So whatever the cost, I put positive, and the positive, we put negative, because we say costs. So it means whatever positive, that is the costs, not the typical net present value when the one up above the time scale that we put that here positive, and something out pocket it put negative. So with that, we calculate the LBC 532,996 for the base case, and alternative 502,863. And that with that one, as you can see, the costs for the overall cost, consider the whole life of alternative A is less than base case, about 30,000. So it means that we should choose alternative if we consider the total costs of this system over 20 years period. If you consider only the initial cost, so this one, and you can see for sure you more base case cheaper. However, cheaper is always good in the long run. And this example is show you that aspect. And now with a lot of hand calculation, how can we do that with the program? And that is the second problem that we asked to do here is the use the same problem, but use the Building Life Cycle Cost BLCC program developed by the National Institute of Standard and Technology to solve that same problem, whether we get the same answer. So that is the subject we want to solve. So with that, if we go back to the program, go to Building Life Cycle Cost, click in here, the second button, and now it seems they have a program available for both PC and Mac. If you do the homework, if the Mac doesn't work for you, team up with the people, with the student, have your friend with have PC so that you can do that. So you can download this one for Windows, this one properly for Mac. And when you download that, install in your laptop, you can, or computer, and then it will be shown in BLCC, stand for Building Lifecycle Cost Program. Okay, so that one, if I open, if you already installed, open it up. So it will be here for that. So you can open Building Lifecycle Cost Program. And if you want help, you can see how they analyze for different scenario, what is the data. Some have a built-in data that we can use. Some you can add, customize for the problem you want to solve, right? So it's very important to take that in mind. So the even financial admission calculation, all of that involved if you want to get more in-depth of that. So let's go directly to we want to use that same project to do, which is problem 2 in that life cycle cost analysis. So you go to new, file, new, and select the first item energy project, because HVAC. So put it down here. So when it that, you may save that file, set as for the project you want in your local. Let me go in here. I put in my drive, but you can put in anywhere in your, put there. So it's a LCC demo, save. So you can put your project name. So you see LCC for problem 2. Problem 2. And location, it will be drop down, Florida, analysis, who doing, me. End of year discounting. For the problem here, we have the 6% per year discount rate on a 20-year study period, and the useful life is 20 years. So with that, we can plug in the go to the next step, key dates. You see that, go to key date. But before that, we put the discount rate, and our is 6%. You can always go back to change, and then key date. Let's do it start in January 2013, and you can do that in your homework, the upcoming homework. Service day from base day. So basically, sometime when you start investing, you may not be used immediately. So like the construction project, you start spending money, initial costs. January 2023, you start construction, but it may take 1 or 2 years to bring the project to service. So that is how far from the start day that you spend money, initial cost, to put the project in operation. In this case, the HVAC system. So here I just assume 0 years. So it means that start immediately, just like put the HVAC system and we can use immediately within a day, like that. But you can put, like, if a construction, you can put 2 years or something, depends on the schedule for the project. The length of study period, what is the life you analysis in this problem, they give us 20 years. So 20 years here, useful life of 20 years. Okay, so go back, general information, Florida, add alternative. So we have two alternatives, base case and alternative. So you can add those two to the program. So first is base case, right? With alternative, and then you have base case in here, and then you can go back to the project. You can add 6%, change 6% here. Key date, January 23. Add alternative. You can say alternative A. That way the project is here. So we have two alternatives. Set up framework for that one. Make sense? So we have a base case and alternative, and that exactly to the two here. So that goes you the overview when you start the program, how to create the framework with alternative in the BLCC building life cycle cost analysis. In the next video, I will show you how to provide input for one alternative, and then you can do the similar for the other, and we can show the results.